Consider a rifle which has a mass of 2.44 kilograms and a bullet which has a mass of 150 kilograms and is loaded in the firing chamber. When the rifle is fired, the bullet leaves the rifle with a muzzle velocity of 444 meters per second. And this question has 10 parts to it, so I've just decided to do each part separately and just say the question. So part A asks, what will be the momentum of the rifle immediately before the bullet is fired? So this is actually pretty simple. First, let's just assume that before the bullet is fired, the rifle isn't moving. So the person is holding the rifle and he's not moving it around. So we'd say the first let's write our data, but I'll lead to what I meant to talk about in a second. So the mass of the rifle is 2.44 kilograms, and or is like subscore or whatever you call it, and the mass of the bullet, this right here is in grams, so we'll just convert that to kilograms. So that would be dividing it by 1,000, which gets us 0.15 kilograms. And the velocity of the bullet, you could say V subscore BF, as in the velocity of the bullet after, but beforehand they're both the rifle and the bullet are one system, so I didn't, and this would be 440 meters per second. So now this is actually the first part's a pretty simple problem. We're just saying, let's assume that the system isn't moving at the start, right? So that means the sum of the momentums is 0. So that would mean, and we can say our momentums are the initial momentum of the rifle and the initial momentum of the bullet. Yes. So here we're just saying, let's substitute. Okay, actually, let's just say anything multiplied by 0 is 0, right? So we're just saying that equals 0 because momentum, and also let's write another pretty important equation before we get started on this. That is the equation for momentum, P equals mv. So now let's look into the momentum of the the momentum of the rifle. So beforehand, the bullet isn't moving, so its momentum beforehand is 0, and its mass is 0.15. So that would be 0 plus the momentum, the mass of, and you can already tell the answer is going to be 0 if you want to look into it. However, I just have to write everything out because this is still, actually, yeah, we can just write PRI. Yeah, so I just need to write everything out. However, it's really obvious. So PRI equals 0. And we can say that makes sense because I said we can assume the rifle and bullet aren't moving to start with, and obviously if something isn't moving, it has no momentum, right? So that's the answer to, and make sure you put an A over here beforehand. That's good enough, right? Let's just draw a bit of a line here and go on to part B. What is part B? Part B says, what will be the momentum of the rifle-bullet combination before the bullet is fired? Oh boy, what do we do now? Well, we look at the equation, sum of P equals 0 equals P B I plus P R I. Actually, you know what? I'll go ahead and say, well, no, okay, yeah. I'll just, there's really no other stuff. Like, there's no step 3 here. You have the answer there. So I'm just gonna maybe steps 3 and 4, or that's the sum of the equals 0. This is just, in fact, we kind of had to assume this, but it's almost a given because no, it's not a given. It's really common sense. So for step 5 here, I said, let's see. Yeah, it does make sense, as we can assume the rifle and bullet aren't moving to start with. So again, same concept as that. Now let's move on to questions, and you can see these initial questions are quite easy. So C, what is C? What will be the momentum of the bullet immediately after the rifle is fired? So here we actually have to do something. So how are we going to work this out? Well, first of all, we have the data over here, so we don't need to really rewrite it. But all we're doing is saying P equals mv. We have the velocities and the masses, the mass and velocity of the bullet before or after the bullet is fired. So yeah, we just say P equals 0.15. That's this times 440, and let's label this BF, or just PB works, but whatever you want. Do whatever you want. Right, so 3, that's step 3, and 4, we get PB equals 66. And this is in kilogram. Oh yeah, I forgot to write in units, but yeah, write in kilogram meters per second, kilogram meters per second, and kilogram meters per second. So that is, it is letter C. As you can see, they're not that hard at the start. Now for okay, let's do something over here. Let's resize all of this to be a bit smaller. Let's not actually. Let's pretend that never happened. Okay. So now let's start from scratch. Okay. For D, the question is, what will be the momentum of the rifle immediately after it has been fired? So we're looking for the PRF, or PR, whatever you want to call it. So our data, we have that the momentum of the bullet is 66 kilogram meters per second, and we have that the sum of the momentums is 0. So that is P, actually I'll just write PR plus PB equals 0. So we have that PR equals negative PB. Well, hey, we have PB, right? So we're just saying, let's say that's step, yeah, hold up. Let's say this is step 3, right? Because we have to have some work. And then PR equals negative 66 kilogram meters per second. Whoa. Kilogram meters per second. And we can say, yes, this makes sense because law of conservation of energy. So that would be your step 5. Law of not energy, momentum, my bad. Law of conservation of momentum, LOCOM. So yeah, that is step D. Oh, I always forget to write the letter. Yeah, step D, or yeah, step D. Now let's go on to step E. What will be the momentum of the rifle bullet combination immediately after the bullet had been fired? Okay, so now we actually have to do work. Can you believe it? So let's see. Here what we're working with is we have the let's see. Oh no, we don't. Never mind. I take it back. Right. So you have the sum of momentums equals 0. So the sum of momentums beforehand equals the sum of momentums afterhand because of the law of conservation. I don't know if yeah, no, that I guess that would still be a law of conservation of momentum equals 0, right? So there we have it. That's our answer. The sum of momentums after as pretend I hope you're writing the letter not like this, write the actual letter. So yeah, that's it. Law of conservation of momentum. Okay, we're just, as you can tell, we're burning through the next. It gets harder later on. Okay, now we have to actually do work. Okay. So for step F, we are asked, what will be the velocity of the rifle immediately after the rifle has been fired? Okay. So here we're working with, again, the law of conservation of momentum, and the sum of, we're going to use the same equation. We're going to say PBI plus PB or PRI. Actually, let's just skip this. Let's say PB plus P. So we're talking about the final momentums over here. PB plus, so the final momentum of the bullet plus the final momentum of the rifle equals 0, right? Because we just found that out here, right? These are the finals again. So that means, let's see. Or we could, actually, I take that back. What we could do is we could just say we have the momentum of the rifle, right? So we're just using P equals MV here. My bad. Okay, so the momentum of the rifle is negative 66 kilogram meters per second. Its mass is, I think, no, 2.44 kilograms. And that's how we find the velocity. And now I'm going to say VRF, because VRI is different. Though, anyway, yeah, just go with it. So VRF equals negative 66 over 2.44. And you get, for step 4, that the answer to F is around negative 27.05 meters per second. And I'm kind of cutting it close on time here. Step F, there we go. And this makes sense because, let's see, it's a pretty light rifle, so it's gonna have a lot of kickback. It's only 2.44 kilograms, which is, I guess, around a pound. 2.44 kg to lb. Oh, we're really cutting it close. Never mind. Okay, it's about 5 pounds. So it's not exactly the lightest or the heaviest